This film is about a fluidized bed tea dryer developed in Sri Lanka by the Tea Research Institute in collaboration with Colombo Commercial Company Engineers Limited. This is the first machine of its kind anywhere in the world. First, let us look at a conventional tea dryer. It is a convection type dryer where the medium of drying is hot air, which enters the dryer at the ground level, flows upwards and exits through the opening at the top. Wet tea is fed at the topmost level and dry tea is discharged at the ground level. Tea to be dried is spread on perforated trays which are mounted on endless chains. Thus, tea is conveyed forward and backward and exchange heat and mass in 4 or 6 passes with the hot air stream. Typically, the thickness of the tea layer on perforated trays is 10 to 15 millimeters. The drying time is usually 21 minutes with a hot air temperature of 195 degrees Fahrenheit, 90 degrees centigrade. This is the fluidized bed tea dryer. But first, let us see what fluidization is. It is a physical state achieved by solids, in this instance wet tea particles, with the help of a fluid, in this instance hot air. A fluidized material behaves like a fluid. The efficiency of contact between fluidized solid particles and the fluid being very good, it is an excellent method of heat and mass transfer. In the fluidized bed tea dryer, tea is fluidized on a perforated sheet. These perforations are carefully milled on the stainless steel sheet. Hot air forced through these perforations supports a thick bed of tea and makes it fluidize, and material is dried in the process. This is a general view of the TRI-CCC fluid bed dryer. It has a trough type configuration where wet tea is fed from one end and dry cooled tea is discharged from the other. It is constructed in segments. Hot air for this dryer is generated in an air heater or a heat exchanger furnace and is sent in through an underground duct. Flow level dampers are provided to distribute hot air to different sections in required proportions. Waste level dampers are provided to adjust the direction of airflow just below the perforated plate. Inspection windows provided allows the operator to see the inside of the dryer. Just over the perforated plate, with a clearance of about 10 to 15 millimeters, an oscillatory type stirrer is provided. This stirrer helps in fluidizing the wet tea mass by suppressing formation of blowholes. The frontmost section of the dryer is fitted with the feeder bank, which is provided with a 2-flap feed rep spreader and an indicator. The last drying section is provided with a weir whose height is adjustable. Hot dry tea is discharged over this weir into the last section, which is coupled to a cooling fan. Thus, hot dry tea is cooled before discharging out of the machine. Thermodials showing the inlet temperature and the outlet temperature are fitted at the feed end of the dryer. These temperature readings help the operator to manipulate the operation of the machine. Both these temperatures are also recorded in a thermograph. The outlet temperature referred earlier is the temperature measured by thermoprobes immersed in the fluidizing tea bed near the discharge weir of the drying section. In oil-fired installations, inlet air temperature control is done by on-off thermostats. Now let us look at the machine in operation. The recommended inlet air temperature is 260 degrees Fahrenheit, 127 degrees centigrade, and it takes over 1 hour for the dryer to reach this temperature from startup of the furnace. Once the air temperature reaches about 240 degrees Fahrenheit, 115 degrees centigrade, the feeding of material is commenced. The rate of feed of material is at operator's disposal. In the Sri Lankan style of tea processing, wet tea contains about 55% moisture. The aim is to reduce the moisture to a 3% level. It takes about 15 to 20 minutes for the dryer bed to get filled up, and once filled, dry hot tea flows over the weir into the cooling section. The weir is set at a height of 75 to 100 millimeters. The extent of drying is monitored by measuring the temperature of fluidizing tea just before the first weir. That is, fully dried fluidizing tea just before cooling. This temperature is maintained at about 200 to 210 degrees Fahrenheit, 93 to 100 degrees centigrade, by suitably adjusting the feed rate of material. Cooled dry tea discharged from the cooling section is then collected on trays and taken for further processing. In order to efficiently operate this machine, it is necessary to ensure that the degree of fluidization is satisfactory. If the flow rate of air is insufficient, proper fluidization cannot occur, even with the help of the oscillatory stirrer. Wet tea gets stewed under this condition. This is quite undesirable. On the other hand, if the flow rate of air is too excessive, fluidization becomes too aggressive. This leads to inefficient use of the drying potential of hot air. Correct fluidization in all sections of the dryer is the secret behind efficient operation of this machine. Now let us look at two air heaters which are commonly used along with fluid bed dryers. This is an oil-fired heat exchanger. The volume of air sucked through the heat exchanger can be adjusted by the operator to get the optimum requirement of the dryer. The fan delivers hot air to an underground duct which is connected to the dryer. The oil burner is thermostatically controlled, automatic type. The oil flame is confined to the central combustion chamber, which is made of heavily finned cast iron. Clean air and flue streams are through annulus pathways. The machine at the far end is a recent design of a dual fuel air heater, primarily meant for use with firewood as the source of fuel, with the option to switch over to liquid fuels. Here too the operator can adjust the volume of air to choose the dryer requirement. Although fuel feeding is done manually, necessary control of temperature can be easily achieved. The capital cost of a fluidized bed tea dryer, complete with a heat exchanger or a dual fuel heater, is just over 50% of the capital cost of an equivalent size conventional dryer system. On the other hand, the cost component on fuel in a fluid bed dryer is 30 to 40% less than a conventional dryer system. Although there are many makes of fluidized bed tea dryers in the market today, this original design has remained very competitive, mainly because of the simplicity of its design.